Hi, this is Alex from devstories.eu, Learning dspy, episode 13 of 15. Automated agents are great when you have a loose, open-ended task. But when you need absolute deterministic control over exactly how, when, and if an external function is fired, handing the wheel completely to the language model is too risky. You have to pop the hood and manage the execution yourself. That is exactly where manual tool handling for control comes in. Using an automated agent loop abstracts away the execution layer, which can cause unpredictable latency or hide runtime errors. Manual handling is the power user alternative. It restores your control over error recovery, timeout limits, and exact execution order. To build this in dspy, you start by wrapping a standard Python function using the dspy.Tool class. Imagine you have a Python function that acts as a calculator to multiply two numbers. You pass this function into dspy.Tool. If your function handles database queries or network requests, you can also wrap asynchronous functions, and the tool class will manage the async execution natively. Once your calculator tool is ready, you must expose it to the language model. You do this by passing a list containing your tool directly into a dspy predict module. You define a parameter called tools in your predict call. When the model processes the input, it evaluates the prompt and decides if it needs the calculator to generate the final answer. When the model decides to use your tool, it relies on an underlying mechanism called an adapter. By default, dspy uses a JSON adapter. This adapter automatically translates your Python tool into the native function calling format required by the specific language model API you are using. This ensures the model outputs reliable, structured JSON when requesting a tool. Pay attention to this bit. It is easy to assume that using native tool calling automatically produces higher quality outputs. The dspy documentation explicitly warns that this is a misconception. Native tool calling provides better reliability for the syntax of the request, but it does not guarantee better reasoning quality than standard text-based parsing. The model is not suddenly smarter just because it is formatting JSON. Because you are managing this process manually, the model doesn't actually run the calculator. It stops and returns a response containing its intent. You access this intent by inspecting response_outputs.ToolCalls. This property returns a dspy.ToolCalls object, which behaves like a list of instructions. Each item in this list specifies which tool the model wants to use and the exact arguments it generated, like 5 and 10 for the calculator. Next, you write a standard Python loop to iterate through these requested tool calls. For each call, you manually invoke its execute method. Invoking execute triggers your actual Python code using the model's generated arguments and returns the result. If the arguments are invalid or if the calculator throws an error, your Python loop catches it. You handle the failure on your terms rather than hoping an automated loop recovers on its own. Manual tool handling cleanly separates the model's decision to request an action from the physical execution of that action, giving your application the deterministic reliability that production environments require. Thanks for listening. Happy coding, everyone.